adding and subtracting unlike fractions. The first step we take is we look for common factors of the two fractions that we're adding or subtracting. So let's look at this simple example of thirds and ninths. Let's say that we're either adding or subtracting two different fraction types that are thirds and ninths. So first of all, what we'd do is we'd see if one has a factor of the other. So looking first at thirds, we're interested in the factors of 3. Now 1 times 3 equals 3, so those are factors that we could be considering for thirds. And if we look at ninths, we're interested in the factors of 9. And of course we have 1 times 9, so 1 and 9 are factors, but we also have 3 times 3, so 3 is a factor. So both of these fractions have 3 as a common factor. And because 3 is a factor of 9, it means that we can just cut up the thirds to create ninths as well. So it's shown as seen on screen now. Now this example was run through in the previous clip, and this is what we'd call a simpler addition or subtraction, because we're actually able to change just one of the fraction types to match the other in the sum or subtraction. However, this isn't always the case that there'll be a common factor, and we're going to explore these trickier examples in today's clip. So, what do you do if they don't have common factors or you're unable to change one fraction to match the other? What we do next is we look for common multiples. So first we look for common factors and then we look for common multiples. So let's look at this example on screen now. What we have is 1/6 coloured in, and we're adding 2 ninths. So now we have two quite different looking fractions, and the first step is to look for common factors. They both have a common factor of 3, because if we look at the 6 is in the 3 times tables, and if we look at the 9 is in the 3 times tables as well. But we cannot change one of these fraction types into the other, because 6 is not a common factor of 6 and 9. So in the first example we just looked at with thirds and ninths, 3 was the common factor, which was also matching the thirds. So that could then be cut up into ninths. But this is sixths and ninths. So because 6 is not a common factor, it won't actually be convertible into ninths. But we have this common factor of 3, so there still is a possibility that we could do something with this. And what we could notice is that both sixths and ninths are possibly simplified into thirds, assuming you have enough pieces to make a third. Now, if we look at 1/6, we only have one small sixth. So we know straight away that if we tried to turn that into thirds, it would be less than a third. So that's not going to work. And just out of interest, it's a similar story for the 2 ninths. We just don't have enough for us to simplify that into thirds. So that won't actually work for us either. So let's start looking at multiples, which is the next step. So the multiples of 6 are simply 6, 12, 18, 24, and so on. We could skip count forever all the multiples of 6. And the multiples of 9 are 9, 18, 27, 36, and so on. And we're looking for one in common, but more importantly, we're looking for the lowest one we can find, because we don't want to be dealing with lots and lots of cutting up of these fractions. We want to keep it as simple as possible. And we can see there that they both have 18 in common. So this is a fraction type that we can convert to. Because they have a common multiple of 18, we know that they can be converted into 18ths by cutting appropriately. So we would need to cut our ninths into 2 pieces each. So each fraction piece would need to be cut into 2. And we can do that as shown on screen by cutting each shape as such, as shown. And then, as a result of that, the light blue pieces that we have also are getting cut into 2. So we've done this process previously, and that would give us 4/18ths. Then if we turn our attention to the 6th, to cut that into 18ths, we would need to cut each piece into 3. Okay, and so we can do that as shown in the picture. And then because every piece has been cut into 3, that means our one piece that we had in light blue also got cut into 3. So we end up with 3/18ths. Now we have two fraction types that are matching, and so we can do our simple addition that we've learnt with adding and subtracting fractions. So 1/6 plus 2/9 is instead being cut up and turned into 3/18 plus 4/18. And so that's simply adding those together as 7/18. And so we've now solved 1/6 plus 2/9 equals 7/18.